Okay, so logarithmic functions are directly related to exponential functions, but they're a little bit different. And a lot of it can't be done in your calculator. So it's a lot of manipulating so that you can figure out answers and graph and things like that. But a logarithmic function, when you're going to let a and x be positive real numbers, but a cannot be equal to 0. So the logarithm of x with base a is denoted by log base a of x and is defined by y equals log base a of x if and only if x equals a to the y power. So you're manipulating it so that you can turn it into an exponential function, which is easier than it sounds, but it's going to take some getting used to. So f of x equals log base a of x is the logarithmic function with base a. Note that the inverse function for an exponential of a to the x is that log base a of x. So that's why we're using exponentials to figure out the answers to logarithms, because they're inverses of each other. So exponential functions undo logarithms, logarithms undo exponential functions. Okay, so in these first three, we're going to evaluate the logarithms. Now, remember, you can't generally just plug a logarithm into your calculator and have it spit out the answer. So what we're going to do is we're going to turn it into an exponent. So the base of your logarithm is going to be the base of your exponent. So our base here is 2. So we're going to have a base for our exponent of 2. We need to find 2 to what power is going to equal whatever that number is. So in this case, 8. Well, 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8. So log base 2 of 8 is going to equal 3. And we just repeat the process for 2 and 3. So 9 is our base of our logarithm. So 9 to what power is going to equal 3. So that's getting smaller. So our exponent has to be less than 1. So think about when we talked about square roots and cubed roots and fourth roots and all of that, we could write all of those as exponents. So if we think about 9 and how we get to 3, well, the square root of 9 is 3. So we could write the square root of 9 as 9 to the 1/2 power, which means in this case, that logarithm is equal to 1/2. And then for number 3, we have a base of 4. So 4 to what power is equal to 1? Well, there's one number that no matter what the base is, if that's our exponent, it's always equal to 1. And that's 0. So 4 to the 0 is 1. X to the 0 is 1. Anything to the 0 power is always 1. So if you have a logarithm with a 1 there, it's always going to be equal to 0. We also have 3 main properties of logarithms. So again, a and x are positive real numbers. A still cannot be equal to 1. So if we have log base a of 1, that's going to be equal to 0, because like in number 3, a to the 0 power is always 1. If we have log base a of a, it's always equal to 1, because a to the first is a. You can also kind of think of it as those a's are canceling each other out. And then if you have log base a of a to the x, that's going to equal x, because a to the x has to equal a to the x. And again, you can kind of think of it as canceling those out, because exponentials and logarithms are inverses of each other. Now we do have a special type of logarithm called the common logarithm or common logarithmic function, that's when you have a base of 10. So you can write it with that base of 10 in there, or you can just write it as log of x or log of whatever your number is. Your common log is one of the logarithms that you can evaluate in your calculator. So when you're evaluating common logs, you can write them as exponentials and try to solve them. Like we could say, okay, I have a base of 10, so 10 to what power is going to equal 1,000? 10 to the first is 10, 10 to the second is 100, 10 to the third is 1,000. So we would end up getting 3 for that. Or you can also type that into your calculator. 3 buttons up from your on button on your calculator, it says log. So you're going to push that log button on your calculator, and you're just going to type in 1,000 because you don't have to worry about a base. You already have a base in there. And you're just going to type in 1,000, hit the enter button, and you're going to get that answer of 3 again, which is also helpful if you're doing one like the log of 42, where you can't easily say, okay, 10 to what power is going to give me 42, because it's not going to be a whole number. So we're just going to type in log of 42 in our calculator. So hit that log button, type in 42, and you're going to write down that rounded decimal answer. I would at least go to 3 decimals. You can go to more, but make sure you do at least 3 when you're rounding those logarithms. And then same thing with number 6. Hit the log button, square root 3 divided by 2. Make sure that when you do the divided by 2, you're not still in that square root, because that will give you a wrong answer. But that's going to give you about negative 0.062. So evaluating common logs in your calculator, super easy, super straightforward. Okay, so when we're sketching graphs of our log functions, the easiest way to do it when it's not a common log and it's not one that you can just plug into your calculator is you're going to do the exponential inverse of it, because then you can just flip the ordered pairs. So we're going to look at f of x equals 3 to the x so that we can use that to graph g of x equals log base 3 of x. So I'm going to use my normal negative 2 to 2. So 3 to the negative second is 1/9. 3 to the negative first is 1/3. 3 to the 0 is 1. 3 to the first is 3. 3 squared is 9. So when we need to find our ordered pairs for our logarithm, we're just going to take those values and flip them. So instead of negative 2 1/9, for the logarithm, x is going to be 1/9 and y is going to be negative 2. And then 1/3, negative 1. 1 0 3 1 9 2. So we're just going to use those to graph. So I'm going to graph my exponential first. So negative 2 1/9, negative 1 1/3, 0 1, 1 3, and 2 9. And then graph log base 3 of x. So 1/9, negative 2, 1/3, -1, 1, 0, 3, 1, and 9, 2. So those graphs are just inverses of each other. So I would encourage you to try this one on your own. Get your ordered pairs for f of x for your exponential function, and then reverse those for your logarithmic function. So I'm going to use the same 5 values for f of x. So 1/2 to the negative second is 4. 1/2 to the negative first is 2. 1/2 to the 0 is 1. 1/2 to the first is 1/2, and 1/2 to the second is 1/4. And then for our g of x, for our logarithmic function, we're going to end up with 4, -2, 2, -1, 1, 0, 1/2, 1, and 1/4, 2. So it's just reversing them. And then all we have to do is graph them. So my logarithmic, -2, 4, -1, 2, 0, 1, 1, 1/2, and 2, 1/4. And then our logarithmic, which is just the reverse of that, we've got 4, -2, 2, -1, 1, 0, 1/2, 1, and 1/4, 2. So in 9 and 10, we're going to identify the transformation from y equals log base 2 of x to sketch the graph of h of x. So when we compare number 9, h of x equals 3 plus log base 2 of x, to y equals log base 2 of x, we've got that plus 3. So when we've got a 3 added, or any number really, added or subtracted to a logarithm that's not connected with that variable, it's going to move it up or down. So this is just going to add everything up 3 units. So just for the use of the table in numbers 9 and 10, when we're looking at the regular log base 2 of x, so for 2 to the x, we're going to have this table, which means for our logarithm, we're going to reverse those. So when we're looking at what to do with this table for log base 2 of x compared to this one with our 3 plus log base 2 of x, we're just going to move all of those up 3 units. And what I would encourage you to do is to start to plot them where they're already labeled for, and then just move them up 3. So 1/4, -2, we're going to move up 3 units, and it becomes 1/4, +1. And then 1/2, -1, we move up 3 units, and it becomes 1/2 positive 2. 1, 0, up 3 units, becomes 1, 3. 2, 1, up 3 units, becomes 2, 4. And 4, 2, up 3 units, becomes 4, 5. So the shape's not going to change. All that's changing is we're moving it up 3 units. So number 10 is a little bit trickier because we've got a negative x inside of the logarithm. And when we've got a negative kind of in the parentheses with our function, that's going to reflect it over the y-axis. And when we reflect over the y-axis, we change the sign of our x values. So we've got our table for log base 2 of x. That I'm going to rewrite here. And when we need to make it so that it's a negative x instead of a positive x with our logarithm, we're just going to change the sign of our x values. So a negative 1/4, a negative 1/2, a negative 1, a negative 2, and a negative 4. And that's what we're going to graph. So we've got negative 1/4, negative 2, negative 1/2, negative 1, negative 1, 0, negative 2, 1, and negative 4, 2. So same shape, just reflected over the y-axis. So just like in exponentials, when we have that natural exponential with the letter e, we also have a natural logarithmic function which has a base of e, and you can write it 2 ways: log base e of x, which is really not common, or ln of x, so natural logarithm of x. The ln is the button that you're going to have on your calculator for this, which is right below the log button on your calculator. The properties of your natural logarithms are the exact same as the properties of our common logs. The natural log of 1 is equal to 0 because e to the 0 is 1. The natural log of e is equal to 1 because e to the first power is e. And natural log of e to the x equals x because e to the x equals e to the x. And again, you can kind of think as the natural log and the e canceling out because it's the same base and the same value. So when we evaluate 11 and 12, you can use those 3 properties, or you could also use your calculator. So if we use our property for number 11, the natural log of e to the third, well, that's going to be property 3, where they said that the ln of e to the x equals x. So this is going to equal 3 because that natural log and that e are essentially going to cancel out. But if you wanted to put it in your calculator, you would just hit the ln button, and then you would do second of ln to get that e value again, and type in your 3 for your exponent, close your parentheses, and hit enter, and it's going to give you 3. For number 12, you can do it in your calculator again, or you could rewrite that as ln of e to the negative second so that you don't have that fraction. Either way, is up to you, whatever you're comfortable with. But either way, you're going to get an answer of -2. So if you're worried about making a mistake and it's natural log, just plug it into your calculator. Okay, so when we are graphing natural logs that we can do in the calculator, one thing that you have to keep in mind is that it said that your x values had to be greater than 0. So when I make my tables, I just start at 1. So if I were to plug in 1 for x and then add my 3, I'm going to get 3. If I do natural log of 2 plus 3, I'm going to get 3 plus 693. If I plug in 3 for my natural log and add 3, I'm going to get 4.099. If I plug in 4, I'm going to get 4.386. And if I plug in 5, I'm going to get 4.609. And I'm just going to plot those points. And they're going to be really close together. So you just want to keep in mind that it's going to have that same natural curve as a logarithm. Or if you wanted to pick larger numbers so it was more spread out, you could do that too. So we're just plotting those points. So it's got that same kind of curve as our logarithm functions. So I'm going to do the same thing for number 14. So I would encourage you to try that one on your own and see what you come up with. So when I plug in 1, I'm going to get 0. When I plug in 2, I'm going to get -6.693. When I plug in 3, I'm going to get -1.099. 4 is going to give me -1.386. And 5 is going to give me -1.609. And then I'm just going to plot my points. So when I connect my points, it's going to be the same kind of curve. It's just going to be going the opposite direction. It's just going to be flipped over the x-axis. So if you need to evaluate a logarithm and you can't evaluate it easily, you can use what's called the change of base formula, or you can use it to even just change it to a different base completely, but usually it's used to approximate a logarithm value. So your most common is going to be to use either the natural log or the common log. Doesn't matter which one. You're going to get the same answer either way. The only thing you want to make sure you don't do is you don't use a natural log for the numerator and a common log for the denominator, or vice versa. So if we wanted to evaluate log base 9 of 36, I'm going to use my common log and I'm going to say, okay, I'm going to do the log of 36 over the log of 9. And I'm just going to type those into my calculator. Make sure you're closing the parentheses after you type in your 36 and your 9. And it's going to give me approximately 1.631. And then I'm going to do it again for 16, only this time I'll use natural log. So the natural log of 0.72 over the natural log of 2. I'm going to type that into my calculator, making sure I'm closing the parentheses. And it's going to give me negative 0.474. So I'm going to ask that you guys pause it and try 17 and 18 on your own, see what you get. Use common log, use natural log, doesn't matter. So for 17, log of 16 over the log of 1/4. Which is going to give me negative 2. And then 18 log of square root 42 over log of 4. So that is your logarithmic functions. Let me know if you have questions.